Hello children, so welcome to AIMS India's online classes. Today from physics subject, a measurement topic we are going to learn. So if you observe the pictures here children, so here we are having one instrument called tape. So where you might have observed this kind of instrument. So if you go to any tailor shop, for measuring the cloth or for taking your measurements for stitching the cloth, pant or shirt, he will make use of this instrument, which is a measuring tape used for measuring small kind of instruments. So this is a clock. This is clock. Means in the clock 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like that. We have some markings here. With the help of clock, we can measure time. So this is a so this is used to measure length, whereas this is used to measure time. Used to measure length and used to measure time. Or if you take the help of common balance, if you take one common balance, what the common balance will do, it will measure the mass. It will measure the mass. Like that, we need, for measuring length, we need an instrument tape. For measuring mass, we need an instrument of common balance. For measuring time, we need an instrument of clock. So like that, with the help of some instruments, we can measure some quantities. Okay. So here, so measurement means it's an action. It's an action of measuring something or some amount of stuff. So measuring something, that action is called measurement. So why it is important to measure distance, time, or accuracy? Why there is a need of doing measurement of all these things? Why means we can have a better understanding of the world around us. So if we measure anything, then we can have a complete idea of that object. Or you have taken a book into your hand. Somebody, they ask you, tell me about the book. Can you tell about the book without reading the book? For telling about the book, you have to read the book completely, so that you will get some idea regarding what is the book is about, what are the characters in the book. Like that, after reading, you will get complete clarity regarding the book. Then you can answer any question. In the same way, suppose one object is there, one brick is there. So if suddenly by seeing the brick, you can just tell it is a brick. You cannot explain about it. But if you take some tape, you can measure its length, you can measure its breadth, you can measure its height. Or if you take some common balance, you can measure its mass, you can measure its area, you can measure its volume. Like that, you can have complete idea of the object with the help of measurement. So that for constructing one house, how many bricks you need, what kind of bricks you need. Suppose while coming in tractor, what is the load of tractor, how many tons of bricks you have brought for constructing home. Like that, you can have complete idea of the object with the help of measurement. Without measurement, if you want to construct house, if you need bricks, what you have to tell, bring some that many bricks. Like that, you have to tell. If they bring that money, what is that money? They will not have any idea regarding that many, this many, bring some bricks. Like that you can't tell, because that words, they won't give complete description of the requirements. Or if you go to tailor shop, if you go to tailor shop, you want to make a switch, make him stitch a shirt for you, or school uniform for you, shirt or anything for you. So without, just by seeing you, can he stitch? He can't. He has to take your measurements. So your shoulder length, your neck length, your hands hands length, hands length, and your chest length. All these measurements he has to take, and how much length, how much long shirt should be, or if we like that, all measurements he has to take. So then only he can stitch the shirt for you. Otherwise, he may stitch shirt for you, but it will be suitable for you somebody else, not to you. Like that, it may happen. So we should need measurement. We have to make use of measurement for complete understanding of the object. Complete understanding of the object. So measurement is extremely important. Very, 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 very important, because they shape the way we think. The way we think and interact every day. The way we think and interact every day. In what way we are thinking, what is our complete exact requirement, that will be identified only with the measurements. Only with the measurements. So let's now today we are going to discuss about these words, mass and weight, because about this length and time in your earlier classes you have discussed, children. So in today's class we are going to learn about mass and weight. Mass and weight. Suppose this girl, she is telling, my mass is always 56 kg. Or this girl is telling, my weight on the moon is around 90 newtons. Same girl, my weight is around on earth is around 560 newtons. Same girl, she is giving three different type of statements. So one time she is telling mass, when other time she is telling weight. That weight also, on the moon different weight, on the earth different weight. This elephant also, if it's a funny picture, children, because this balance cannot hold the weight of a elephant, it will break. So it's just a clip art, children. So okay, so we have to learn about the terms mass and weight, and why there is difference in weight on the moon and earth. That reason we have to know, and what is the relation between mass and weight of the same girl. Here the girl is telling mass, here she is telling weight. Why she is telling like that? That reason also we have to know. Next one, mass. So mass means the quantity of matter which a body contains. Means the whatever object you take, in that the original quantity of matter, how much matter is present in that, that is called mass. So this is same whenever the body is, wherever the body is. So mass will be same everywhere. It is measured in kg, kilograms. So mass means actual or original, actual quantity of matter which does not changes. So there are three states of matter: solid, liquid, gas. All of these contain atoms, molecules that make up mass of the object. So the mass of the object means because of matter. What is matter? It may be in the form of solid, liquid, gases. What do they contain? They contain some atoms or molecules: hydrogen atoms, oxygen atoms, water molecules, air molecules, like that. Like that, they contain atoms and molecules. These atoms and molecules make up the mass of the object. Make up the mass of the object. So if my mass was 65 kg, 65 kg, if my mass was 65 kg, this would be true wherever I went in the universe. I may go to any planet, I may go to any star. I may go to any galaxy, but my mass will be always 65 kg. Because mass is because of matter. Matter is because of solids, liquids, gases. These are because of atoms and molecules. Wherever I go in my body, inside my body, the number of atoms and molecules does not change. Does not change. Does not change. So just like dress size, because wherever I go, my dress size will be the small, will be the same. So in the same way, mass also will be the same. Number of atoms and molecules in the body will be the same, and mass will be 65 kgs. In the word mass itself, we are having one acronym. M for mass, A for always, S for stays, S for same. D we can keep or we can't. We can or we can't. It's our wish. Mass always stays same. But grammatically it's wrong. Mass always stays the same. Means according to English grammar, which is definite, which won't change. We use the article the before that. That's why mass always stays the same. So M for mass, A for always, S for stays, D, S for same. Mass always stays the same. We are having this acronym. Okay. Next, weight. Weight. Suppose if you are staying on Earth, if you throw a ball into the air, after some time, what happens to the ball? It will fall down. It will fall down. The ball will fall down after some time. Why means the earth is having gravitational force, or which is called gravity. Because of that force, it attracts any objects that is flying, any objects onto the earth. Suppose you may ask why it cannot attract sun, why it cannot attract moon, because they are at larger distances which are away from this effect of gravitational force. This gravitational force, it works around the earth up to some extent. In that region, if any object is there, it will fall down onto the earth. Or you can take the example of aeroplane. Why the aeroplane not attracted by the earth? Why means while going, it travels with a speed of 11.2 km per 7, which is called escape velocity. Means for 1 second it goes 11 km. So that's why its velocity is very fast that earth cannot attract. Gravitational force cannot work, so that it can escape from the gravitational force with that velocity. So on which objects gravity will not work? Which are at larger distances, or which are traveling with escape velocity, or more than escape velocity. On remaining all the objects, the force will act. Means if it acts on the rubber ball, indirectly it is acting on the mass of the rubber ball. This gravity is acting. The mass of the ball is m. Because of gravity, the ball will fall down. Means the velocity of ball changes. Beginning 0 meter per second at the top, next 10 meter per second, next 20 meter per second. Its velocity will change. That change, because of gravitational force, its value is 9.8 meter per second square. So this is called change in velocity because of gravitational force, or acceleration because of gravitational force, or acceleration due to gravity. This small g, it is called acceleration, or acceleration symbol A due to gravity small g, ag, acceleration due to gravity, whose value is equal to 9.8 meter per second square. Means because of this gravitational force, the ball will come down to the earth with this much change of velocity. So that's why it will hit the earth with great speed. Okay, so that mg, this mg combination works on the earth. The combination of this m and g, mass and acceleration due to gravity, this product is called weight. So now the ball will be having mg, weight, on the earth because of gravitational force of the earth. Because of gravitational force of the earth. Okay. So, okay, children. So, weight is a force. Because of, here, weight is because of gravitational force. So, that's why we can consider weight as a force which is measured in newtons. Actually, mass is measured in kilograms. This acceleration due to gravity means change of velocity because of earth, meter per second square, kg meter per second square. For this new, we have another name on behalf of Newton. They have named it as Newton. Sir Isaac Newton, they named it as Newton. So weight is measured in Newton, mass is measured in kilograms. So weight means it's a force of gravity acting on mass that is positioned in the gravitational field. Means around earth, around some space, gravitational force will work. That is called gravitational field. Gravitational field. In the gravitational field, on the mass, force of gravity will work. This changes with strength of gravitational field. Strength of gravitational field. So here, the earth may have one kind of gravitational field. Previously, the moon can have one kind of gravitational field. Strength is less. Earth can have gravitational field more gravitational field. Here, less gravitational field, more gravitational field. Because of that, less weight, more weight. It may be because of that. Because moon also show attraction power on the object, earth also shows attraction power on the object. Earth attraction force is more compared to moon. If there is no attraction force, then it is called mass. Okay, children. So there is an equation which links mass to weight in terms of gravitational field. That equation is W equals to mg, where W is weight in Newton, m means mass of object, kilogram, z means gravitational field strength or acceleration due to gravity at the position where the mass is placed. Okay. So the formula for weight is W equals to mg, where m is mass, z is acceleration due to gravity. So on Earth, z value is 10 newtons per kg, or approximately 9.8 newtons per kg. But Newton means already we have told. Newton, instead of kg meter per second square, they named it as Newton by kg. Kg cancel. We can write 9.8 meter per second square. So z means it may be strength of gravitational field or acceleration due to gravity. In both ways we can take. If we tell strength of gravitational field, we have to use Newton per kg unit, or acceleration due to gravity, meter per second square unit we have to use. So if my weight is 65, if my mass is 65 kgs, so then my weight will be 65 into this 10, because Weight means mg. M for mass 65, G for gravitational field strength 10. 65 into 10, 650 newtons. 650 newtons. So this 650 newtons is true only when I stay on the earth. If I go to moon, I would be very light and jumping would be very easy compared to earth, because the gravitational field strength of moon is 1.67 newtons per kg only. Means compared to earth it will decrease 6 times. Compared to earth, it's the gravitational field strength on moon is 6 times less than earth. It will decrease 6 times. Or 65 into mass 1.67. We have to multiply 65 into 1.67. What is the approximate answer, children? (65) into 1.67. Approximately around 108, like that, 108 kg newtons will come on the moon. On the earth, 650 newtons. On the moon, 108 newtons. Because on the earth, gravitational field strength is 10 newton per kg. But on the moon, 1.67 newtons per kg, which is 6 times less compared to earth. So my weight will be 1/6 of what I did on the earth. Does it mean that I became thinner? No. My size here on the earth, on the moon is same. But because of weight, my weight will, so because of gravitational field strength, if my weight here it shows 100, here it will show 16.6 only. But the atoms and molecules that I made up my mass, that won't change. That won't change. So this is the main difference between mass and weight. Okay, children. Mass means the quantity of matter in an object. Quantity of matter in an object. So its SI units are milligrams, grams, kilograms. Kilogram means 1000 gram. 1 kilogram equal to 1000 kilogram. 1 gram equal to 1000 milligrams. 1000 milligrams. So weighing scale or common balance is used to measure mass. So here Joy weighs 28 kgs. A bag weighs to 5 kgs of apples. Like that we can tell. Difference between mass and weight means quantity of matter. Weight means the gravity pulling on it. The gravity of earth pulling the mass, or how hard the gravity is pulling, or with what force the gravity is pulling. That force is called weight. Suppose for 1 kg object, mass on earth is 1 kg, mass on space is 1 kg, mass on moon is 1 kg. But for 1 kg object, mass on earth is 1 kg, weight on earth is 1 kg, weight in space is 0, because in the space there will be no gravitational force. So that's why all the objects will fly in the space. So weight on moon means in 6 times, 0.166 kg. Okay. So next, difference between mass and weight. So mass means quantity of matter. Weight means the force with which earth attracts the object. Mass does not changes from place to place. Weight of a body is not constant, changes from place to place. Mass SI unit is kilogram, weight SI unit is Newton. The smaller units of mass are grams, milligrams, bigger unit kilogram. There is no formula for mass, but the formula for weight is W equals to mg, where m is mass of body, g is acceleration due to gravity or gravitational field strength. So it is measured by beam balance, weight is measured by spring balance. So how we are going to measure that we will learn in next videos. Okay, children. So this is our topic, children. So today we learned about what is measurement, what is the difference between mass and weight, what is mass, what is weight, so why weight changes from place to place, what are the units of mass, what is the difference between mass and weight. Okay, children, that's all for today. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you. Have a good day.